All right, the last example, number 3. The first thing I do is I look at factored form. The first one is already in factored form in the denominator. The second one is a perfect square binomial, which can be factored into x plus 2 times x minus 2. And then again, I like to change this subtraction to plus and then distribute the negative across the top so it becomes plus and then negative 1 and then x minus 2. All right, step 1, what types of factors do I have? Well, if I look at all the denominators, I have an x plus 2 type of factor, and I have an x minus 2 type of factor. What's the maximum number of x plus 2's I have in any one place? 1. What's the maximum number of x minus 2's I have in any one place? 1. So the least common denominator is 1 x plus 2 and 1 x minus 2. That is my least common denominator. So now I'm going to take that, I'm going to multiply it onto 1, 2, 3 terms. So here I go. There's my first term. Here's my second term. And here's my third term. Right there. Notice I've got the negative 1 on the top. That's what I want. Okay. So, how do you simplify? Well, things should start canceling. I have an x plus 2 here and here. I have both an x plus 2 and an x minus 2 here. I have just the x minus 2 there. So here I get 1 times x minus 2, which is just x minus 2. Here it's just 4. And here it's negative 1 times x plus 2, which is just negative 1x minus 2. And if I solve this, if I add the 1x on this side and add the 2 on both sides and then divide by 2, I get x equals 2. Okay, we have to check this answer. Is that going to work? Can x equal 2? Well, let's go up and look at the original denominator factors. Well, x cannot be a negative 2 right here because that would give me a denominator of 0. Oh, but look here. If I have a 2 value right here, 2 minus 2 is 0. That doesn't work. So if the answer x equals 2 is indeed the answer, it gives us a number that doesn't exist here for the first term. Well, that can't work. So this answer must be rejected because it makes the denominator value here and here, if you think about it, both 0. But really, it just takes the 1. Anytime you get a denominator of 0, that's it. Can't use that. So therefore, I'm going to say that this answer has no solution because both here and the last one give you a 0 denominator. Nope, can't have that. No solution.